resistance to the flow of current. Okay, this is the thing that you have already studied. This is very basics in electrical. Similar way in heat, in thermal, what is happening? This is one end. So what is going? Heat is flowing through this material. It is transferring from one end to the another end. So the flow is heat. Here the flow is current. Here the flow is heat. One end is at the temperature of, here I should use some color pen so that you can differentiate. So this is at a temperature T1, this is at temperature T2. Okay, so the change in temperature is delta T. Here the change in voltage, here it is at one voltage, here it is at another voltage. So the change in voltage you have already noted that as delta V. Here the temperature is changing, Q is passing through this. So Q is always transferring from higher temperature region to lower temperature region. So this temperature region, this is T1 and this is T2, and this resistance is thermal resistance. This resistance is thermal resistance. So thermal resistance is nothing but resistance to the flow of heat. That is thermal resistance. So that this is the electrical analogy. Okay, so thermal resistance you can say R for conduction, which is equal to L by Ka. This is the thermal resistance, which is denoted as R, which is equal to L by Ka. So the difference between electrical and the resistance concept for electrical and thermal is, here the flow is current, here the flow is heat. Here the difference in voltage is delta V, here the difference is temperature, which is delta T. Here this resistance is electrical resistance, here this resistance is thermal resistance. This is the resistance concept and electrical analogy. Next, heat transfer through fins. That is the next topic which is given in this syllabus, that we will see. Let me see this heat transfer through fins. So what is fins? First we will discuss about what is fin. Why we need fin? What is the use of fin? We have seen so many real-time applications about fins. Okay, electrical engineers are not only electrical engineers, we all people have seen the motor, right? In our house or some industrial area, we have seen the motor. At the outlet periphery of the motor, there will be some blades which are attached to the base of the motor, that are called as the fins. When motor start rotating, that fins are kind of blades which are attached on the base of the motor are called as the fins. Or if you take engine, okay, mechanical engineers very well know about that. Engine cross section is at the outlet of the engine. There are so many fins, okay, extended surfaces which are projected from the base of the engine to transfer the heat effectively, that are called as the fins. Okay, so fins are also called as extended surfaces to transfer the heat effectively. Okay, so what is fins? Suppose you take Newton's law of cooling. What is Newton's law of cooling? Q is equal to H into A into Ts minus T infinitive. This is the Newton's law of cooling. In this, suppose there is one body, like I will draw. Okay, so let us assume this is one rectangular object, okay, on which I have attached one extended surface, like this is a fin, this is fin. Okay, it's a kind of rectangular fin I have extended from the base of the object. Okay, why I have extended this from the base of the object means, suppose this is one plane or any object. Suppose you consider this is an engine cylinder. I know that I have already fixed the engine cylinder temperature should not exceed 80 degrees Celsius. If it exceeds 80 degrees Celsius, then the engine will get damaged. So that the design engineer will design the engine cylinder which should withstand the temperature up to 80 degrees Celsius. So this temperature I have already fixed, which can go up to 80 degrees Celsius only. I cannot or I should not operate the engine more than 80 degrees Celsius. So I know that, so that I no need to change and I cannot change that temperature. And this T infinitive, which is also fixed. Why it is fixed? Because at what ambient that I can operate the engine is also fixed. Suppose engine is like we are driving a bike. Where we are driving the bike? We are driving on the roadside. Means in atmosphere only we are driving. In atmosphere the air temperature is 28 degrees Celsius. So that is ambient condition. So that I know that ambient condition, I cannot increase the temperature of the atmosphere. So that temperature, that is T infinitive, is also fixed. So I cannot change that Ts and also the T infinitive. And when coming to this H is nothing but heat transfer coefficient. That also I cannot change. For design I will fix that value, which is heat transfer coefficient. At this ambient, this will be the heat transfer coefficient. Suppose if I take the room ambient or any other ambient, suppose if I take 28 degrees Celsius, the air is like natural convection. So for natural convection, the heat transfer value will be between 5 to maximum 15 or 25 only. Suppose if I take that particular object into some other air medium where the air is forced to flow over the object, in that case the H value will be more than 25 to 100. So where also I am fixing the value, that fixed value will not be varied and you cannot vary that fixed values. So this H value also fixed. So in the formula 3 values I fixed. What are they? T is also fixed, which I cannot change, I should not change. T infinitive is also fixed, and this heat transfer coefficient is also fixed. So I cannot vary these 3 values. Now one and only option is available, which is area, which I can change. I can change the area. How can I change the area? See this. Initially it was like this only, like the plane wall. Okay, so this surface you say T naught, base temperature of the wall, which is T naught, and the ambient is T infinitive. The two are fixed and area also something like that only. If I keep the system like this, then the amount of heat transfer will be very less. Suppose I want to increase the heat transfer, I have to extend the surface. So if I extend the surface by like this, so what I did here, carefully you understand, this particular part, this particular extended surface is called as fin. Fin is also called as extended surface, which is used to increase the area of the surface so that you can achieve more amount of heat transfer from the particular body. So only by varying the area we can increase the dissipation rate of heat by this kind of fins. So there are so many types of fins available. This is a rectangular fin, pin fin is available, okay, and also splines are there, okay, triangular fins are there, okay. Based on the application we can choose the fin and number of fins also you can choose, and the gap between the two fins also you can choose, area of the cross section you can also choose. So that so many parameters are there to design the fin for the particular application. But here you no need to study more depth about that fins, formulas and all, no need. If something else we will discuss in the numerical problem. For that, at present, for time being, you understand the theory things only here. In the later we will solve the numerical problems where we will see in depth about these formulas and also the numerical problems based on the fins also we will discuss. So that the theory behind the fins, what is fin, what is the use of fin, you should understand that fins are used to dissipate more heat. Whenever we, like suppose if you take any electronic component, okay, so that suppose you take any processor, okay, always processor will dissipate more amount of heat. So what will happen, suppose if the surface is like this only, so you cannot achieve more amount of heat dissipation rate. What the thermal engineer will do after this, that this system they will give it to the thermal engineer. What the thermal engineer will do, they will place one kind of fin with some base plate. These are the fins. So number of fins they will attach on the top of the high power dissipator component. This is the source of heat. From here only heat is dissipating. If I keep this as a plane, so I cannot dissipate more heat. Why I need to dissipate the heat if I am not able to, or if I am not dissipating the heat from the electronic component? Suppose one IC is there, the maximum temperature for that particular IC is fixed to 90 degrees Celsius. So that if I dissipate heat, that temperature will be maintained below that maximum temperature. If I fail to dissipate the heat, then the temperature of the IC will be increasing, that will be crashing the more than the maximum allowable temperature. It should not be like that, then that will damage the whole system. It should not be like that. So I will think that how to dissipate the heat. So that fins are used here to dissipate the heat. Usually fins we will use when there is a possibility of convection. Without convection, fins, if we include the fins, that is not effective method to transfer the heat. If there is only conduction, then you no need to use the fins. If there is a convection, and you can use a convection also, preferably we can use forced convection. If there is a forced convection, then that is well and good for fins type of heat transfer method. So like this we can increase the heat transfer rate by utilizing the fins. And here if you see that number of fins are there, that also you can decide based on your application, how many numbers required and how many what is the gap between the two fins. Okay, these many things are design procedures for fin. Okay, so this is the concept about the heat transfer through fins. Okay, next one is unsteady state heat conduction and lumped parameter system. This is the another topic. Okay, next one is unsteady state heat transfer, also called as transient heat transfer. What is this unsteady state heat transfer and transient heat transfer? I forgot to tell you one thing in the Fourier law of heat conduction, where we assumed that the heat conduction happened in steady state. What is steady state and unsteady state type of heat conduction? Steady state heat conduction means we are assuming that there is no changes in the temperature with respect to time. That is called as a steady state heat transfer. Okay, unsteady state heat transfer means there is a change in temperature with respect to time. That is called as a unsteady state heat transfer, which is this topic. Unsteady state heat transfer, also called as transient heat transfer or heat conduction. So what is unsteady state heat conduction means? The best example for the unsteady state heat transfer so that you can easily understand. Suppose if you take during summer season or any climatic period, you take the wall or any kind of object which is exposed to the atmosphere. Morning 9 a.m. if I touch the wall of my house outside, it will be like 28 degrees Celsius to 30 degrees Celsius, equal to atmospheric temperature. If I touch the wall during high summer season like April or May month, if I touch the wall afternoon 1 o'clock, then it will be like 38 degrees Celsius in heavy summer season. So even again at 3 o'clock if I touch the wall, it will be like 37 degree or 36 degrees Celsius only. Now if I touch the same wall evening 6 o'clock, then it will become 29 degree 30 degrees Celsius. What is happening? The temperature is varying with respect to time. This is the best example for unsteady state heat conduction. So the temperature variation which is dt with respect to time, which is not equal to 0, that is called as transient heat conduction. Okay, transient heat conduction. And by another topic is like transient heat conduction or unsteady state conduction is nothing but the temperature is varying with respect to time. Temperature is not constant, okay, always it is varying with respect to time, is called unsteady state heat conduction. Followed by one more topic is given. You remember this, we are covering only the definitions of all the topics and theory behind that. What is that, what is it, how it is used, and what is the use of this, these things only we are seeing, and some basic numericals we will see, definitely I will take. Now you understand that basics, what is the meaning of the sentence which is given. Next, lumped parameter system. What is a lumped parameter system? Lumped parameter system means that is called as unsteady state heat conduction, comes under that only. So lumped parameter system means, suppose if I take one pan of water here, okay, lumped parameter I am explaining. What is lumped parameter? Here one potato is there which is at 100 degrees Celsius, okay. Now this water is at 30 degrees Celsius. What I am going to do, I am going to immerse this potato inside this water, okay. So now the potato came inside this water. Now after some 10 minutes, this potato temperature will reach 80 degrees Celsius, okay. So that time this potato again alone I am taking outside. This is the potato. Now the temperature of the potato is 80 degrees Celsius, and here for lumped system I am assuming that temperature is the function of only time. Temperature is not the function of x, y, z. Temperature is the only function of time. Okay, what happened? I immersed the potato which is initially at 100 degrees Celsius into the water. After some time, the temperature of the potato came down to 80 degrees Celsius. Now, what I am saying, for lumped system, temperature is the function of only time, not the function of x, y, z. Okay, what is the meaning for that? What is t is equal to f of t? What is t is not equal to f of x, y, z? So here what I am assuming, this is the one assumption, this is the second assumption, and third assumption for the lumped system is it has infinite thermal conductivity. The lumped system has infinite thermal conductivity, and also the fourth one, conductive resistance will be lower than convective resistance. Means 10% of convective resistance is conductive resistance. Conductive resistance is just 10% of convective resistance. Means what is meant by conductive resistance and what is meant by convective resistance, you need to understand. Okay, conductive resistance means, conduction means what we said, conduction is happening only in solids and liquids and gases also. Here this potato you consider as a solid. So inside the potato all the molecules are closely packed. Okay, what will happen? Due to molecular vibration, the heat will transfer from one molecule to another molecule. Here I am saying conductive resistance is negligible comparing to convective resistance. If the resistance value is less, then the conduction of heat will be high. The formula for that Q we have seen what? Delta T by R, which is T1 minus T2. This is the heat conduction equation for plane wall, which we have seen already. T1 minus T2 by R is equal to L by Ka. So this I can simply write this equation always, all of you please remember, Q equal to delta T by R, where R is the thermal resistance which is inversely proportional to Q. If the R value is less, then Q value will be high. Okay, so here I am saying internally the conductive resistance is high, and also I have written one point, it has infinite thermal conductivity. So the thermal conductivity is infinite. Okay, or the material is homogeneous, okay, and isotropic. So the heat will be transferred like this internally. So this point if you take, there also the temperature will be 80 degrees Celsius. If you take at this point, there also the temperature will be 80 degrees. So any point if you take on the potato, the temperature will be 80 degrees Celsius only. Why? Because I am talking about the lumped system. Lumped system means the temperature will not vary with respect to the axis x, y and z. It will vary with respect to time only. Now why sir you are telling time varying? Because before it was 100 degrees Celsius, after immersing into water, so immediately it is not reaching 80 degrees Celsius. It is taking some time, so that the water will gain some heat and the potato will lose some heat. So that for that it is taking some time. So with respect to time, the temperature of the potato has been reduced from 100 degrees Celsius to 80 degrees Celsius. That is the first assumption what I have taken. T is equal to F of T. So here the temperature is reduced from 100 degrees Celsius to 80 degrees Celsius, so that temperature is with respect to time. And I am also telling that the temperature if you take any point like x or y or z, any direction if you take, is remains at same temperature only. That's why T is not the function of x and y and z. I think you well understood about this now. Next, it has infinite thermal conductivity. Conductivity means infinite thermal conductivity means it is conducting more heat. It has more conductivity. When it has more conductivity, then it will conduct more amount of heat. Okay, so it is conducting more heat. That's why the temperature is remains same in all the points of the object. That is the meaning for that it has infinite thermal conductivity. Next one, conductive resistance is less than convective resistance. Conductive resistance means inside there is no restriction to the flow of heat. If there is no restriction to the flow of heat, then all the heat will get transferred, then in all areas the temperature will remain same. So lesser, negligible amount. But convective resistance is this one. From here to here there is some convective resistance obviously. That is convective resistance or convective, there is one formula which is 1 by HA. This is the convective resistance formula. This is the convective resistance is this. Conductive is, we have seen already, L by K. So comparing, so what is this from here to here? There is some resistance, like this is my object, on this air is flowing over this pen. Okay, suppose if the pen is 80 degrees Celsius, the air will come and flow over this pen and it will take the heat from this pen and move away. So to take the heat from this pen, this will come and flow over here. When the air is coming and flowing over there, there is a resistance between this pen and the air. So that is called as a convective resistance. Okay. So this is called as a lumped system. So lumped system is nothing but it is a ratio between conductive resistance to the convective resistance. That is nothing but lumped system. Okay. And in that case, what we have found, the conductive resistance is lesser than the convective resistance, so that in lumped system the temperature of the body remains constant in all the points, and the temperature will vary only with respect to time. The temperature will not vary with respect to the position. That is called as, that type of system is called as the lumped system, lumped parameter system. Okay. So these are the topic as of now we have seen. Okay.